Hello, it's Scott Manley here, back with Kerbal Space Program 1.10 because this expansion has added a collaboration with the European Space Agency. I mean, as well as all the usual flags and new parts, this has added a pair of missions. We have Rosetta, a mission that went to Comet 67P Churyumov-Gerasimenko, but today I'm going to play through BepiColombo. BepiColombo brought to you in partnership with the ESA, the European Space Agency. This mission asks you to recreate parts of the currently ongoing real-world BepiColombo mission with an added Kerbal flair. Your goal is to deliver 2 orbital probes to Moho to investigate its magnetic field and planetary features, and finally to reach the surface with a small lander. And to do this, I'm actually going to bring on somebody that knows a little more about the real BepiColombo than I will. So hello, we're here with Elsa. Hi, Elsa from European Space Agency. You're, what do you do at ESA?
Well, I'm the BepiColombo Spacecraft Operations Manager, which means me and my team, we have the responsibility for making this mission reality. So taking it from the ideas and the plans that were developed prior to launch and implementing all that in real flight, making it happen in a sense.
And you're here because we're going to make this happen in Kerbal Space Program.
Yeah, that's awesome, actually.
So I guess you can see what's going on here, right? You can see this glorious homage to the Ariane 5, right?
Yeah. Wonderful rocket with our beloved spacecraft on top of it. Yes, that was an emotional moment for me when it happened in
October
imagine. 18.
2018, yeah. October 2018.
Yes.
So actually, what I'm gonna do is wait for the launch window because I want to perform a flyby of a planet in between us and our destination. In Kerbal, we're going to go to Moho, which is the innermost planet, but in real life, BepiColombo went to Mercury. And it's called BepiColombo. Why?
Well, it's the name of a scientist, actually, a mathematician from Italy. His real name was Giuseppe Colombo. Bepi is a nickname of Giuseppe in Italian. And he played a very important role for Mercury science. In fact, he advised NASA about orbital change they could give to their Mariner 10 spacecraft in the 70s. And thanks to these recommendations, the Mariner 10 spacecraft managed to fly by Mercury 3 times, returning the first data from a man-made machine that we've ever had. So it managed to map the planet to 45%, and even found out it had a magnetic field, which at the time nobody expected. So it was really the first step of further discovery and study of Mercury by mankind at that time.
But yes, BepiColombo is launched just a couple of years ago, and it just flew by Earth, and we're going to have the launch in Kerbal now. So, Ariane 5 is a liquid hydrogen 2-stage rocket with strap-on external boosters that are running, solid boosters, right? And it launches from South America, from the Guyana spaceport in Kourou, right? French Guiana, sorry. And so the Kerbal version, well, it has a little more oomph, right? It can, in real life, the first destination of BepiColombo was a gravity assist to get down towards Mercury. What was the first planet it flies by?
Well, it was Earth. So it came back after 18 months.
Yeah, so why do we go directly to Earth rather than straight, say, to Venus?
Well, it's about that it gives us some more flexibility with the launch date. So in the course of the project, we have had a mission option that would launch directly towards Venus for the first gravity assist of Venus. But these options were rare. So I've encountered one in 12 years on the BepiColombo pre-launch. So it doesn't happen every day. Instead, by putting a gravity assist of the Earth, you control the parameters much better, and then it gave us, it's one aspect that contributed to give us 2 opportunities per year, nearly, over the last 10 years. So that was quite convenient.
All right, I read one paper where what they specifically said was that if you launch directly to Venus, then you need to perform a course correction, and you would ideally do that with chemical propulsion because solar electric might not be able to fit in, the necessary margin in the time, so it shrinks the accuracy needed. So by doing that long arc away from Earth, you can get this Earth encounter trimmed perfectly, right?
Yes, it's really about saving fuel to one aspect. This is what you said, yeah. And I mean, on the real BepiColombo, we are very constrained in terms of what we can do with chemical propulsion fuel on the transfer module, called also MTM in Kerbal. So it's the same acronym we use. We have much more margin in fuel and in delta V on the electric propulsion system. So in fact, the chemical propulsion system of the MTM is mostly there to help us desaturate our reaction wheels, which we do with chemical fuel, and it gives us a little bit of correction delta V for the swing bys, but we don't have much more than that. And doing a deterministic maneuver for a ballistic mission can cost hundreds of meters of delta V, and we have
if you get it wrong,
in the budget. Well, okay,
yes.
Sometimes it depends on the mission computation, basically, and if you catch the right moment for launch and so on, but it can be very expensive. So that's a choice we made of going with an Earth flyby, which, as I said, is more economical and gives us more flexibility with the launch date.
Yeah. So in Kerbal version, I have to launch into this inclined orbit. Most players of the game will launch directly eastwards just because that's the easiest. But if you're going to go for an interplanetary transfer, you want to get into exactly the correct inclined orbit here. And obviously, when I'm doing this, I'm pretty much doing it by the seat of my pants, so to speak. I'm throwing out the orbits and trying to guess where they end up and trimming things back and forth. But you have a whole team that worked on this for years to get the exact orbit figured out, right?
Yes, we do. I mean, Kerbal makes it look, shall I say, easy? I mean, it's not easy, but this tweaking of the orbits in the visual way, this is really nice. Actually, makes it very intuitive. I don't think it's done like that in real life.
Oh yeah, they have a lot of software, but you have a lot more constraints to figure out. One thing I note, for example, is that you want to make sure during one of the Venus encounters you don't get too close because of extensive eclipses, so that ruled out some trajectories.
Yes, that's correct. Yes, we have constraints in terms of also the duration of eclipse that we can survive. The thermal radiation that we get back from the planet. So, for example, in the case of Mercury, we are not allowed to fly by on the sunlit side of Mercury because otherwise all this energy will get back to the spacecraft, and it's not designed for that. We will fly by as close as 200 kilometers from the planet. And okay, we only reach this altitude towards the end of our extended lifetime in the real mission. So there is really a trade-off to be found there. So yes, the communication is a constraint. How close we can get there with EP is another one. So in real life, we need time operationally around the flyby to fit other operations. So we have to interrupt the electric propulsion arc ahead of the flyby, typically a month before, and leave the spacecraft stable afterwards to recompute the trajectory after the flyby before we can do a correction maneuver. And all this is built into the trajectory also. Yeah. These are aspects that are not visible in the game.
Of course. So, I mean, I've just performed my my transfer burn using the upper stage of the Ariane 5. And the game doesn't force you to get rid of that upper stage. You can actually cheat and bring along a big Ariane 5 upper stage if you like. But I'm playing this realistically for you. So I'm getting rid of it. I'm going to fly by solar electric for the rest of the trip.
Yeah. I think I've noticed you are doing really like a delayed ignition by the rockets, yeah, which is a perfectly.
Oh yeah, because I wanted a circularized orbit. Yeah. But yeah, the initial arc was 1.5 years before it left in October 2018, and it just came back in April. And later this year, it's going to fly, or is it next year? It's going to fly by Venus.
No, it's this year on the 15th.
Yeah.
15th of October 2020, we'll have the first flyby of Venus. Yeah.
And so that's me in deep space trimming my orbit using solar electric propulsion here. Now, the solar electric propulsion on the real BepiColombo, the specific impulse on this is correct here. It's about 3,200 seconds of specific impulse. But the thrust that BepiColombo gets with its 4 engines is 290 millinewtons, right? Something about that.
Yeah, it was designed for 290 millinewton. In the end, we will only operate it up to 250. But that's okay. Similar order of magnitude, basically.
But we're talking about 0.05 millimeters per second acceleration. That's you would have to look very hard to see that accelerating.
Yeah. It's but it's over time it's powerful. Yeah.
Yeah. So and that's going to run during mission for like 2 years combined burn time over all the maneuvers, something like that.
Yes, it's okay. I don't have the exact time in mind, but it's a long duration in total. Yes, and but the most time we fire the electric propulsion is actually when we get closer to Mercury. So in the current period of the mission, from the Earth flyby, including the 2 Venus flyby, we are mostly ballistic, let's say. So we do swing-by correction maneuvers with electric propulsion for a couple of days here and there. We will have one at the beginning of August this year, and we will have another one later this year, and then one next year. But it's nothing compared to the longer arcs we will have when we are in the vicinity of Mercury, where there we use the EP essentially to meet the next Mercury rendezvous, so the next flyby. So we have 6 flybys of Mercury, and we use EP to join from flyby to flyby, let's say. It's something that would be quite tricky to do from a pure ballistic point of view, or would require to embark a significant amount of chemical propulsion fuel again. So.
Yes, so when you're crossing multiple planet orbits, you can sort of bounce back and forth between them and trim your trajectory. But when you're only crossing the one planet orbit, you need to use the solar electric propulsion to make sure that each successive encounter is slowing you down and bringing your orbit down, right?
It's really a matter of doing the rendezvous, because in terms of delta V, we are getting in total, I think, something like 17 kilometers per second delta V from all the flybys combined.
And about 4 from the propulsion.
And about, in fact, less. The mission was designed to accommodate about 4 from the propulsion, but on this particular mission option that we are on, with a launch in October 18, the trajectory only requires 2.7. It's a very cheap trajectory.
Wow,
it wasn't always like that. Yeah.
So you'll have fuel left over when you get there, no?
Yeah. We have in the budget about 1 kilometer per second margin for navigation and contingency.
Oh, cool.
And it's about 700 meters per second on top that we get from filling in the tanks that we have on top of that. Yeah. So it's really, Xenon is... okay, I hate to say comfortable in operations. We don't use that word. But
you just love big margins, right?
Yeah, we like.
Yes, I mean, I did a 2 Venus or 2 Eve encounter. The second encounter is mostly just to change the plane of my orbit so that it gets into the same plane as MOHO. MOHO again is Eve and MOHO versus Venus and Mercury. That's, little green men, alien planet names. And so yeah, now I'm on a position where I'm mostly trimming my orbit and mostly using the solar electric propulsion. This is where I'm going to use most of it. So now I'm also, I guess it's worth talking right now that you guys are, of course, dealing with all these missions. You dealt with a flyby and you're in lockdown, right? How did things work out? Are there special rules to make sure that cats don't accidentally send commands to spacecraft?
Well, okay. Critical commanding is all done from the center, actually. So for the flyby itself, we were at the center. We have a team of spacecraft controller that controls BepiColombo, as well as 3 of our other interplanetary missions, or 2 Mars missions and Solar Orbiter, the latest one, who joined the family. And they are the one who actually release the commands to the spacecraft. But of course, everything needs to be prepared beforehand. And for an event like a flyby, a lot of the work is actually the preparation beforehand. I mean, it's the detailed navigation to put the spacecraft on the right trajectory to meet the swing-by point with the required accuracy. And the preparation for the spacecraft operations, which in our case for the Earth flyby, we had to take care of a relatively long eclipse, 34 minutes long eclipse. And when you fly by the Earth, you have issues with communication. So the antenna we used to communicate in deep space would blast the Earth with too much energy when it's close, and this is not allowed. So we have to switch communication to our low-gain antennas, which are designed for near-Earth communication. We only use them at the launch and at the flyby, essentially. And this requires some care, and it's a bit different from the way we operate the rest of the time. So we had to prepare carefully of that.
So yeah, like preparation would include having special sets of safety procedures, like safing procedures, uploaded, so that if something happens, it knows what to do?
Well, the spacecraft embarks a lot of autonomy as per design. So there is a lot of surveillances on board already, which are pre-programmed from the design done pre-launch. And this is basically has various tuning, if you like, for the different phases of the mission or the different configuration, but this is all there. What we tend to tune is the contingencies that we would have to take over. So basically, the most famous one is a safe mode recovery. So when the spacecraft detects a fault and it cannot continue, it will reconfigure itself and put itself in a safe configuration from energy generation and communication point of view, switching off everything that's not essential. And in the case of the Earth flyby, because we have to change the communication scheme, we had to design a specific recovery procedure for safe mode, which, this is the type of thing you put a lot of work, and then we spend 2 days in that configuration, and of course we didn't need to use it, but you need to have it and to train it. So we do simulations as well. Luckily, we had done most of those before the lockdown started due to coronavirus. So
you knew it was coming, so you'd planned.
We plan ahead, that's why.
Well, the designers of this mission have planned ahead as well, and they've thrown in these interesting little text box from people that worked on the mission. This is talking about the insulation that was used. But I'm not going to read that because you can read that while you're playing the game. I'm trying to get into orbit. But I'm doing this with the ion, solar electric propulsion, and I have 10,000 times the amount of thrust you have. So I can do a direct orbital insertion. I feel like I'm cheating. How does BepiColombo manage it?
Yeah, for BepiColombo, it's going to be actually the most critical phase of the mission. So first, we're going to have to approach Mercury. So the final approach we will do with the reminder of the electric propulsion and some chemical on the MTM. But then eventually we need to jettison the MTM with sufficient time to actually get to know the MPO before it's critical. So typically 60 days before arrival, we will get rid of the MTM and commission the MPO subsystem so that we can keep doing the approach with the MPO chemical propulsion system. And then we use a technique called weak stability boundary. We will exploit the gravity of the Sun and Mercury to get to a sweet point where when we arrive, we're on an heliocentric orbit, but when we get out of this door in space, we are basically more or less captured by Mercury in a natural way. So this requires extremely precise navigation because you need to arrive at the right moment in space, time, velocity, and direction of your thrust of your velocity vector to really get to that point where you enter orbit naturally. The beauty of this is that if anything should not go quite right, we are bound in the Mercury system for sufficient time that we can correct. That's a big advantage compared to a big Mercury orbit insertion maneuver, I think like the one you're doing, right? Where you fire your thrusters for hours sometimes, but then if anything goes wrong, you have lost the mission or you need to redesign a new mission to try and come back, which can be very tricky. So we decided to do it this way this time. Let's see how it goes. I mean, it puts some other challenges onto the operations. It's
a lot more math, I'll know that.
Yeah, I think it's going to be much more. We're going to have to really fine tune the navigation extremely precisely, I think, with this one. But it gives us flexibility again, so it's a good thing for us.
So BepiColombo's actually 4 different spacecraft all bolted together. There's the Mercury transfer module that gets you there, and then there's the planetary orbiter and the Japanese magnetospheric orbiter, and then there's a sun shield. So that's like 4 different pieces that all go to Mercury.
That's right. So it's 4 different modules, which implies also 4 different configurations, which for us operators means actually 4 different spacecraft. And 3 of them we get to know only for a very short period of time because we will jettison the MTM, the MMO, and the MOSIF within less than 3 months from each other. So some of these configurations are quite short-lived, but still they require in the design specific safe modes, specific logics, specific control gains, parameters, and so on. So most of the modes are common for the 4 configuration, but they get tuned slightly differently depending on the configuration. So it's operationally it's a bit complicated, but we had to do it this way.
Yeah.
So,
but the first actual spacecraft that gets deployed in Mercury's orbit will be the Japanese magnetometer magnetic field probing spacecraft.
Yeah, that's right. It gets in a large elliptical orbit to study the magnetic field, and they're the first one to be delivered there into their scientific orbit by the MPO. I mean, in this case, the MPO acts to the MMO as another rocket stage, a little bit. So
the Japanese it has small amounts of propulsion, but it's not going to be making major maneuvers.
Not for orbital control. Yeah. So it's a spinner. So basically, it really requires to be put in the right orbit. In this case, by the MPO side of the mission.
And so once that's deposited, then it will be a case of slowly dropping the orbit down to the second orbit, right, for the main spacecraft.
That's right. Which, in your case, you can also do in one go. In our case, is the whole MOI sequence. So from the moment we enter, we capture around Mercury to the moment where we reach the MPO orbit, it has to be broken down in a sequence of 15 maneuvers. And some of these maneuvers, we don't want to spend our time doing maneuvers during the MOI. We want to start the science. So we want to do this as fast as possible, but we can't really do maneuvers closer than 2-3 days. I mean, any maneuver requires that we collect radiometric observables from the ground stations to reconstruct the orbit of the spacecraft, and then re-optimize the sequence of maneuvers based on this orbit, compute the parameters of the next maneuver, get them, process them, put them into command, send them to the spacecraft with margin. So this whole process it can be compressed, but going below 2 days is really tricky. So,
right, and when you're doing that, it limits your scientific opportunities. And so the science team are saying, let us do science, and you're saying, let us maneuver the spacecraft. And
yes, and on top of that, I mean, constraints again, Mercury is this, very tough environment for the spacecraft. So there are parts of the orbit of Mercury around the sun where we are not allowed to use the thrusters. When we are in eclipse seasons, we are not allowed to use the thrusters. So it's when we're in solar conjunction, we don't have communication for about a bit more than a week because the communication line is blocked, and therefore we don't want to maneuver in these conditions. It's not safe to do so. So there are over the orbit of Mercury around the sun, there are zones where we cannot maneuver. Okay, we will probably do a bit of science and get to know the environment better. But it means that the whole sequence gets stretched quite a bit, and it's going to take us nearly a bit more than the full orbit of Mercury around the sun to complete it. So a bit more than 3 months, which is quite large, but okay.
But then once you're there, that will be left in that orbit doing the science and creating new, better maps and collecting information about the polar regions where we think there might be ice.
Yes, that's very exciting. Also because the difference between BepiColombo and Messenger, which orbited Mercury before us, is that BepiColombo will fly, the MPO part will fly much closer to the planet. And we will start with the argument of pericenter on the north side, but then the orbit will naturally drift such that after a few months, it will start going on to the south side, which Messenger was not able to study with the same accuracy as the north side. And the scientists are extremely excited about this. They're already pinpointing the craters they want to look at and to complement the data. So it's basically about adding more accuracy and knowledge to the data set that was written by Messenger. Also with some experiments that didn't fly on Messenger, for example, or infrared spectrometer, MERTIS was not this type of instrumentation was not present on Messenger, so it's adding to the collection of data that we have.
Messenger looked really well at the North Pole, but it never got close to the South Pole. It was on this eccentric orbit because they didn't have enough delta V left over to bring them all the way down. And BepiColombo has been built with much better, a much more capable propulsion system.
Well, it's propulsion, but it's thermal as well. Huh? The advantage of flying a highly elliptical orbit like Messenger is that you basically balance the thermal load in the sense that you are very close to the planet for a short amount of time, and then you fly out and you can recover a little bit from a thermal point of view. Whereby BepiColombo will be basically in this very demanding thermal environment virtually all the time. So it had really deep implication on the design of the spacecraft and on the technologies that were required to actually make the spacecraft compatible with this environment, which have contributed to the long time it took to get BepiColombo off the ground. So that's one big difference between the two also.
Yes, the game very specifically goes into details of some of the technology that was developed so that BepiColombo could spend so much time in this very hot environment. And the one that caught me was the solar cells, how they had to validate them to the environment, and they have active control systems to make sure that they don't get too hot by being angled too much against the sun.
Yeah, in fact, the solar array, if I may, the solar array are really for operations one of the things that have very deep implications for our work, because as you said, the qualification of the cells was a difficult process, and in order to have no constraints in operation, we would have needed to qualify the whole material and substrate, the cells and everything up to 350 degrees. And we managed to qualify just a little bit above 200. So as a result, we need to off-point the arrays continuously as we rotate around the planet. And this is requiring that we embed a thermal prediction software into our commanding loop, which I can tell you is something that,
something you got to watch
as well. Choice, yeah. We would maybe have preferred not to have it, but okay, it's mandatory for this mission. So it required a lot of work during the design phase together with the spacecraft manufacturer to get this model and come up with a concept in the first place. Yeah, it took a while.
So there is one thing that the game implementation adds, because we don't have a budget, and of course ESA did have a budget, and that is the lander, which was planned in it. And they wanted to put a lander, a 40-kilogram lander, I believe, on the one of the poles inside a crater.
That was in the very early days. I never got to know the lander. I joined in 2007. It was already gone.
Well, I'm obviously getting to do this as the finale, and in my case, I have to be very careful because when we get close down inside a crater, we're not going to have line of sight to Earth. So the parent BepiColombo spacecraft will act as my relay. So this is one of my favorite things in Kerbal Space Program is landing spacecraft, and I'm doing this entirely by hand. I'm not letting a computer do this. But the difference is, of course, I have extremely good instrumentation. But yeah, I looked at the designs for it. It was a 40-kilogram lander. I believe it had 7 kilograms of instrumentation, including a micro rover concept. I mean, of course, when it's a concept that doesn't actually fly, you can say it has anything.
Yeah, exactly. Then reality takes over.
Reality takes over. Mass budgets kick in, and but BepiColombo is, it's an amazingly designed mission, especially when you look at what it did over previous missions, over Mercury and Messenger, and it'll be great that we get to see, deep down, close inside some of these craters, and perhaps get some, good information. Because one of the funny thing about Mercury is that, while it has some of the hottest places in the solar system, it also has some of the coldest. Some of the craters at the poles are permanently in shadow because the axis of rotation of Mercury is exactly aligned with its orbit. And that's part of the dynamic mechanic that Giuseppe, BepiColombo, figured out. That Mercury has this 3-to-2 resonance, which means it rotates 3 times for every 2 orbits, 2 times for every 3 orbits. I always get that mixed up. But, and that's down to a gravitational interaction with the sun. And that also constrains its axis of rotation, so the polar craters are permanently shadowed. And there could be any ice that gets in there, it's probably going to stay in there. So...
Yes, ice and organic material. Who
organic
knows?
material,
yes.
yeah.
So, it's no. I know the community is extremely excited about this. They of course the collaboration with the colleagues from Messenger is in place since many years, and they are looking at this. As I said, the planning for this is already starting on their side. They are looking at the craters in great detail and what this means for the planning of the observations. How quick we can start looking at this in the mission. Because the idea with BepiColombo is that initially we would do a survey mission. So the spacecraft is designed to observes the planet in a nadir mode, so basically always keeping its observation axis perpendicular to the planet's surface, and only doing depointing later to catch up with details or refill gaps or look at interesting parts. But of course, now that Messenger has returned all this data, we already have an idea of the part of the planet that we would like to study in more detail. So we are looking at trying to merge these two objectives, let's say, because the mission is quite short. Yeah, we have a baseline mission of 1 year with a built-in extension of another year. But we always say the mission is quite short, and then our spacecraft get to live for another 20, 25 years. So people are tend to get a bit, some expectations. But I think with BepiColombo, it's unlikely it survives 20 years. So, I mean, the orbit will be stable.
But it's going to take 7 years to get there, right? And the first Mercury flyby is next year. But it's going to be a few more years before it actually gets into orbit around Mercury, right?
Yes. It arrives in December 25. So
yeah,
and then we will be in orbit in the course of 26. And then the environment is so harsh that they were doing tests in our test center in ESTEC, and you can see how this beautiful white ceramic surface gets burned very rapidly, and it turns into a ugly brown very quickly. And of course, this will change the properties of the material and the protection that the materials are giving to us. So we're going to have to see really how fast this whole thing degrades and how much lifetime we can squeeze out of it. So, which is why the scientists are really keen on addressing, not waiting too long to address certain objectives that are coming out of the messenger data, so that we gather everything we can while the spacecraft is still there.
But yeah, so we've actually completed the mission in Kerbal Space Program, and you've
excellent, well done.
Yes, I got a success. A winner is me. So yeah, this is going to be in Kerbal Space Program 1.10, and I understand you had a go at it earlier, and you managed to get to orbit of Kerbin.
Yeah, I'm a newcomer in Kerbal. I find it amazing, the game, but it's just lack of time. I have a family with two small kids, so it has to wait a little bit. But I was really impressed. It's beautiful.
Just get the kids playing it. That works for me,
Yeah, they're just a tiny bit too small yet, but
they like
them
exploding things.
Yes, yeah. An addictive part.
But it's fabulous. This will be in Kerbal Space Program 1.10. Everyone will be able to play these missions and understand what European Space Program is doing. There's another mission for Rosetta, which is another mission very close to my heart. I'm a big fan of asteroids and comets. But I'm really glad that you've joined us here and shared all these insights. So thank you very much, Elsa.
Well, thanks for having me. It was very nice talking to you, and I'm excited about the Kerbal version of BepiColombo. It's very well done.
Yes, I'm sure. We'll look forward to many more people playing it out there, and of course, look forward to BepiColombo, the real one, getting to its target.
Yes, rendezvous 15th of October at Venus. So see you all there.
Yeah, fly safe, right?
Thank you.
So I'm very grateful that the European Space Agency saw fit to collaborate on this project. I think it's a great way to bring the mission that the European Space Agency is performing in science to players of one of the best space simulation games out there. I'm also grateful that the developers of Kerbal Space Program let me have this early and set up this great little meeting with Elsa. And, I'm sure she was aware of the, number of things that Kerbal Space Program doesn't do quite accurately enough for someone that flies real spacecraft. But on the other hand, it was very validating to show just how much it did do well and how educational the whole experience is. So Kerbal Space Program 1.1 will be released at the start of July, a free update for everybody that owns the game. It'll include the new European Space Agency missions, it will include a number of new parts and some graphics updates for long-term players. So look out for that when it comes out. I'm Scott Manley. Fly safe.